In today's lesson, we're going to be able to draw the electric field lines around a charged particle. So, yesterday we learned about electric field vectors, meaning if you take a positive test charge, now it's always positive, you say, where would a positive test charge go if I placed it right here, for example? Okay, so we put a little positive charge here. Where would that go? That's going to tell us the direction of the electric field. Well, here's a negative charge. If this is positive, it's going to be attracted towards it. And here's another negative, so it's going to be attracted towards that. So my net electric field at this point is the addition of those two vectors, and it's going to be down here somewhere. Now, let's look at a different point. If I look at these two, the one in the middle, if I place a positive charge here, it's going to be attracted towards this. This one is going to be attracted towards this one. And if they're equal, my electric field at this point is 0. Now we can keep doing this for all of our points. Now, it's good to remember, if it's closer, it'll be more attracted to the negative, whereas if it's farther, it's not going to be quite as attracted to this negative. So I add those two vectors up, and I get something like this. So we can keep doing this for all of our points. You should do this for all of your points on your page. But what you'll find is that you're going to have vectors. These are the net electric field vectors. So for example, this one is this one. This one is this one. We can keep doing this for all of our points. Now, another way we can represent the electric field in these regions is, instead of just drawing arrows everywhere, we can draw lines. And these lines can tell us a lot about the electric field. So if we were to follow these arrows down, we'd notice it's going to make somewhat of a curve. This is called an electric field line. Okay? It tells us something about the electric field in each one of those spots. Specifically, it tells us if I was a positive charge and you were to place me here, I would experience a force down in this direction. Or if you were to place a positive charge here, it would experience a force in that direction. So it can tell us a few things, but one of them is the direction that a positive charge, the direction of the force that a positive charge would experience. Now we can do this for a few of our lines, right? If we visualize, we can do this for a few of our points, right? If you I made a few more points on my page so that it would be easier to draw, but we can visualize it would look something like this. We can keep doing this for all of our points. What you're going to get is, if you should try this yourself, but what you're going to get is a diagram that on the left side it's going to look like this. So this tells us the electric field in any one of these regions. You would do the same for the right particle, and your result should be something like this. In the middle region, there's no electric field. It's getting pulled towards it over here, towards it over here. Okay. So there's a few rules for drawing these lines. We gotta visualize, right? This electric field, these lines tell us the direction a positive charge would go. So a positive charge would get pushed away from this positive charge and go in this direction. So these lines point in a direction a positive charge would experience a force. So you put a positive charge here, it's going to get pushed away. You put a positive charge here, it's going to get pushed away from the positive, attracted to the negative, so it's going to go to the right. That's what these arrows show. Now, they start at a positive charge or at infinity. So look here, right? You put a positive charge here, it's going to get repelled away. So all these lines start at the positive and finish at the negative charge, or they would go on past the negative charge to infinity. They end at a negative charge or at infinity. Now, here's another one. The number of lines must be proportional to the amount of the charge. This, if we didn't know the charges on here, we could see, well, how many lines do I have coming out of my negative? 1, 2, 3, 4, 5, 6, 7, 8. Okay, my positive, I would have those 8, these 8, plus 1, 2, 3, 4, 5, 6, 7, 8. So this could tell me, well, I have 16 lines coming out of my positive charge, 8 lines coming out of my negative charge. So it must have twice the charge. This positive charge must be twice of that of the negative. So it tells us something about the strength of the electric field. Or sorry, it tells us something about the strength of the charge. One last one is that we cannot have lines cross. You're never going to have a line cross. What would that mean if it crossed? Well, I would say at this point, the electric field is in both this direction and it's in this direction, and that's not possible. The electric field has to be in one direction for every single point in space. So that's the lesson for how to draw electric field lines. Go on and try the next few examples, please.